Hello everyone and welcome to our webinar. My name is Ernst Eder and I'm the LonWorks Technical Director. Today's speaker is Daniel ZOTTI from Oxitaline. Daniel is a longtime supporter of LonWorks. He's one of our board members and has a lot of experience with different communication protocols. The title of his webinar today is BMS Security Protocol with LON, IzoT, BACnet, Modbus over IP. Yeah, Daniel, I'm curious what we learned today and give it over to you.
Okay, thanks. Welcome to everybody for this webinar. Thanks for LonWorks International for this webinar. I will try to present you the advantage of different BMS protocol and disadvantage in some case, and a small comparison between LON, IzoT, BACnet, Modbus, on-field and over IP. And many questions can be asked, could be asked in this presentation. Why cybersecurity is important, and is it possible to compare some protocol? In first, the small summary, I will present HI and Oxitaline activity. And we try to have some explanation about definition, what is an interoperable protocol, what is a proprietary protocol, what is advantage or disadvantage of each, why the security is important and will be most important in BMS in the future, and which protocol we can use with an argument of security in future. I have started my activity in 1987 on Siemens Automotive. It's not a small company. It was not on building. It's just on automotive activity, and at this time I was responsible for the production functional test, and I have got a large experience on heterogeneous infrastructure product with Ethernet, with database, with different material. And it was a very nice experience. Just a small experience after on a company for developing software and for create some application for customer. And in 1993, I have found and I have created Neuron System. Neuron System was at the end the software company, but at the beginning was a consultancy dedicated for LON automation. And we have got a lot of experience because I was a trainer in French language for a large number of first manufacturer at the beginning. Just for remember, the LON arrived in France in 1992, and I have started in 1993 in April, and I have discovered that this solution in August 1992. In 2013, we have sold the activity to ABB Group, and I have recreated a new company named Oxitaline. For designing never the software, because Neuron System was a software editor, but for creating some infrastructure product, and I will show you just what we do together. Sorry. Yes, we have three range of product. The first range is named Octopus. Octopus is in fact a multi-protocol router with LON, Modbus, BACnet, IzoT, with different advantage, like a bandwidth measurement immediately, and on a screen, a lot of statistics, and also a LED for a default wiring in on each twisted pair. In the twisted pair, in any case, in LON, in Modbus, in BACnet, in IzoT, we measure in fact the capability of the wiring, if it's wrong or it's good, and you have a LED green or red. The second range of product is the OX brass. The OX brass will be, in fact, the cybersecurity router dedicated for BMS, but not only for BMS, because it's a switch, it's a router, it's a VLAN manager for infrastructure, for IP and Ethernet infrastructure. We have 10 plug RG45 with 1 gigabit bandwidth, and 2 ports for the fiber optic. We manage inside, in fact, the VLAN, the IP routing. We generate a DHCP for the local device. We manage some rule for the firewall. We have implemented in the IDS and IPS for the protection dedicated for BMS, but not only. And we have VPN and for client and server for creating some infrastructure, local infrastructure with security. And we have include inside a syslog manager, local or managing in remote, and an open ID server for all web device. We have the third and the last range of product. It's a OX-based LoRa. In fact, we work on the LoRaWAN network, and we can create with this device a local network, and we connect and we manage different generic sensor in LoRa, and we propagate and we convert this LoRa data point information to a BACnet or to a LON, and we can send to the cloud for different usage. In fact, this third product can data log, in fact, each information. He include, in fact, a graphical view with a trend, very simple, and we can export, in fact, the CSV for all data point if you want to use that externally. The free range of our product, the idea and the in French the ADN, the DNA in English normally, the DNA of Occitanie is the simple usage for everybody, and we have inside a lot of software, we have a lot of functionality, we have a lot of feature, but for the user it will normally see more simple. We provide some training and some development specific for customer. The main training we have is all BMS protocol with a lot of protocol work for or used by the team for many years, and for myself for many 10 years and more. It's 30 years. LonWorks integrator training just for integrator. NL facility for integrator. NL facility, it's a new generation tool created 20 years ago by Neuron System, and I continue to propose this training. The BACnet protocol is very, very important because a lot of manufacturers try to work with BACnet without any knowledge, and I train some manufacturer for having a knowledge of the capacity and the capability of this protocol, because the manufacturer do not train on the protocol, but only on the usage of the device using BACnet. We have a last training. It's a LonWorks IoT technology. In fact, LonWorks IoT technology is the IzoT solution, including the LON and the BACnet inside of the device, and we will see just at the end of this presentation. The development, we can work with many manufacturers for OEM customer or for transportation and so on. We have experience also in expertise on field for helping integrator or for helping manufacturer to solve some problem. Some French or international customer and client. It's not only on a large manufacturer, but also a large integrator in France and many other customers. We can ask the first question is it very important to use an interoperable protocol? And if I want to invest or to have a security in my BMS, is the proprietary solution is better than interoperable? In fact, we try to compare a proprietary protocol, a BACnet, KNX, LonWorks, Modbus, in different vision. The first was the level of standardization, openness of the protocol, feature of each protocol itself, addressing service. It's not it's a technical presentation, but I will explain you very simply this idea. Which activity, job, is described by protocol? In fact, the idea is to describe some functional block, and we will see why. And if any kind of protocol, I have explained just before, have an implementation on IP, and for which vantage. The infrastructure device, the repeater, router, switch, gateway, and so on, must or can be found an implementation on different protocol. And we will see that some protocol do not implement some infrastructure product, and we will see why. The historical position, it will be just at the end of the presentation. I have changed the order because I think that we are probably more interesting in the compare of each protocol and the historical position, and when arrive this protocol on the schedule is less important for you. The sustainability is very important too today, because we need to have an eco design, eco conception, and we need when an owner invest in a technology, he need to invest for a large number of years, and we will check if one solution or another solution is more interesting or not. Sensitivity by attack on a field side or an IP Ethernet side, we will see what is the different capability and different more resistance on that. Sensitivity on attack in infrastructure device too, and what is possible to main or to create on an old project. If my installation need to implement a cybersecurity, is it possible in which protocol? And we will see that at the end. Okay, in the year 19, there are a lot of protocols available. and all this protocol was mostly proprietary. The normalization in Europe, in US, tried to define some rule and reduce the number of protocol for having, okay, a good vision of the job. Reducing this protocol, we invest less energy in many solutions. And today we have 3 major protocol standardized in the world: was BACnet, KNX, and LON. Every protocol was normalized, was standardized in ISO. It's over the world. And in the past, it was some wear between each solution. For searching, in fact, the positioning, if the BACnet is better than KNX, then is better than LON, or LON better than KNX. Okay, today the wear is finished, and when it is finished, it was at the end of at the beginning of 2002, 2006. Just because all protocol work over IP, and because each protocol have a solution over IP, in fact, the wear was stopped. It's a simplification of the vision of the lobby in the CN and TC 247, but we are together working with 3 protocols. In fact, each protocol, okay, the Modbus start very, very soon because it started in 1979 by the company Modicon. And just in a couple of years after, the IPv4. Many of the person probably are born after the IPv4 start, but in fact it's a couple of years ago. It's not very far. The BACnet, the AIB, the BATibus, the EHS was started in 1998, 1996. It's just a couple of months ago with 1988. In fact, in 2000, just before 2000, in 2000, no, 2000, in fact, AIB and BATibus are regrouped with a 3rd protocol for creating the KNX. And today we have the KNX, the BACnet, and LON together, and Modbus too, sorry. Modbus was standardized a couple of years ago with industrial protocol with 15 other protocol. It's just it's not a standardization, it's just a regroup. Yes, it's just a summarize of each industrial protocol in use, and it's a 15 protocol in the same document. IPv6 was created in 1919, and we will see at the end what happened during this period. The most important for the world is interoperability. Why? Because in fact, we normally the standardization have as a target or have an objective to be interoperable between 2 devices or 2 solutions. In fact, what is exactly the interoperability? And we will define this point. The second, is it possible to have an interoperability with an application in security? It's very important from my point of view. The first, we try to have a definition of 3 words. interchangeability. What is? In fact, it's just replacing a device A with a device B. You can create that with a lamp. We can create that with a Modbus device, with a LON device, with what you want, just an interchangeability. The second word is interoperability, the most important. What is exactly the interoperability? Is the capability to communicate between A and B. And we will see what they have behind this word. And the third was the functionality. In fact, this third this third idea is just to work in the same direction with a same protocol, at example. And when you send a same set point to two devices, one measure the temperature 16, the second measure the temperature 13, and you define a set point to 20. In fact, one creates some cool, the second heat, and in fact we are not on the same direction. And the most important in these three words is correctly the interoperability. Why? Because in fact, we need to have a standardized common protocol. In fact, at this point, if you use a proprietary solution, we do not have the interoperability, because the most important advantage is to work with different manufacturers for different jobs, lighting, HVAC, access control, fire, in the same network, like you have with your computer. If you use a Mac, if you use a PC from Asus, from Dell, from what you want, you have one protocol only on IP, an example. The second point for the interoperability is a standardized data format. When you send a temperature, when you send a phone number, when you send some things, it's very important that the data is understanding by everybody they receive. It's exactly the same between when you send a mail, you have a format and you define at the beginning if it's in UTF-8 or if it's in ASCII or what you want. And in fact, we have defined in the IT the capability of the interoperability between different solutions. Same interpretation of data I have explained, it's done. The next point is very, very important for automation on field. It's a functional block. The functional block is the main important activity on all standardized protocol. In BACnet, in LON and KNX, they define some functional block, but not with the same vision, not with the same objective. The idea is to use exactly the same sensor, at example occupancy, for the comfort, the lighting, and sunblind. And in every protocol, like BACnet, KNX, and LON, they have a description of some data point, some property in some case, or some communication object in a third protocol. And we need to create on field some interaction between some object. This is the objective of our protocol. And the objective for the cybersecurity is to maintain this connection between each object, and do not break this connection, and do not to receive a connection from a device not allowed. I have, for the interoperability, two visions. The first is a vertical interoperability. This vertical interoperability is, in fact, when you have a SCADA, you have a database just behind for having description of each data point on field. And in fact, each device need to be receive or send information from the SCADA or to the SCADA. It's this is a vertical communication, interoperability, with the same things. In fact, if I send a temperature, if I send an occupancy, the SCADA or the device do not need to an explanation of which data is. Okay, he understands. And for this this communication, we need two things. The first is a request response, and the second is the event. The event, when you send an event, an example, when you have an alarm on field, the SCADA do not read any information from the alarm. The alarm arrived automatically. It's very, very important for our automation. The second is the horizontal interoperability. This is a second point, very important. In fact, we have a lot of connection between a sensor, between a light, a remote control, HVAC, a window stop the master, and this master send information to the slave. We have a lot of connection. For creating that, we need only one propagate services, is the event. The event is mandatory. In fact, when a person is detected, is sent to the light and is sent to the HVAC. It's the same when you have a remote control. When you press the push button, you ask or you need to have the light and the comfort in the room. For creating that, we probably need also a database for giving a logical address to each device and create any connection, binding in LON, but we are not only working in LON, and we need to create this connection with this link, and we need to apply to this link some property, some service described just after for the security, and we will speak about that. For comparing some protocol, in fact, we have defined some idea, an example item, some standardized protocol. In fact, the Modbus is standardized, but it's just crazy. The LON, the KNX, and BACnet are standardized. I have explained just before. Standardized format of data point is exactly the same. Same interpretation, normally it is exactly the same. For the proprietary, the same interpretation, it's correct because it is between my device and my device. It's very easy to have a same protocol and same interpretation. Functional block by job certified, it is more critical. In fact, in KNX and in LON, the two groups, LonWorks International and KNX organization, have created this functional block. And this functional block describe some activity, some job, HVAC, sunblind, lighting, access control, fire detection, and so on. In BACnet, it's very poor. In fact, we have some object, but the object is not exactly the same than a functional block. A functional block for a light, for a sunblind, have a different data point. An object for a BACnet have just one data point only inside. It's completely different. Is the request response supported by the protocol? Yes, in fact, for every device. And for the Modbus, that example, because it works in master-slave, the master sends a request to the slave and the slave responds. I am pretty sure that the proprietary have exactly the same, and the request response are supported in BACnet, in LON, and KNX too. For the event supported, I have no idea for the proprietary. For the Modbus, it's a void. You can't create an event with the propagation when you modify a register, but in BACnet, in KNX, in LON, it exists. It exists a small difference in BACnet than in KNX, in LON, and we will explain just after. Is it possible to create interaction with independent tools? It's impossible in BACnet. In proprietary independent tool, it's impossible because it's a proprietary software for that. In Modbus, you can't create any connection between two devices. And in fact, with this line, we will see that the only two protocol very open and very standardized and yes, open, interoperable, it is the KNX and the LON. Is it possible to have a centralized database for all address device and all relationship? Why it is very important that? Because if you have a problem on your device and you have an attack or you have a destruction of it, it's very important that all device will be reinstalled, like you restore the database, you restore the email, you restore the application on the computer. You need to reinstall all device, all relationship directly from the database. And this database will be protected and will be backable. The two next point is very important for the certification, because we have, for many, understand that in fact, the certification is important for the interoperability. And in KNX, in LON, we have the certification functional block for the thermostat, for the remote control, and any things. And we pay for that, and we have a certified device, a certified document. And this certification can allow that an integrator can manage your device very easily. For the BACnet, it's different. In fact, the certification is only based on the revision of the protocol, but he includes some object, and you have some object inside, but it's not an object dedicated for the HVAC, example. They have implemented the light, they have implemented some fire detect, but you have not a large number of functional blocks like we have in KNX and in LON. The certification is defined by the revision of the protocol, and you pay for each revision. And for the KNX and LON, the protocol, the stack is for free, because it's mandatory. You follow different layer. In fact, the certification in KNX and in LON is for layer 7. We will see just after, and the BACnet is on bottom of layer 7. The layer is very important, because in fact all kind of protocol support or not the 7 layer. A model of communication propose a layer 7 layer. Layer 1 is just a conversion of medium. You can support the twisted pair, the fiber optic, IP, and so on. The layer 2 is just how I send a message on my medium, and the calculation of the CRC for the receiving message, just for verify if it's good or not. The layer 3 manage the logical address. It's a device addressing, and we will see unicast, multicast, broadcast, and so on. The layer 4 is the service delivery. Very important if you want to just send a time, or if you want to switch off 2000 lamp, or you send a message to an alarm for a fire. It's very important. We have some service very adapted for the job, and the last service we will see will be the authentication. The layer 7, it's never used in automation, and we do not speak about the layer 5. The layer 6 is a presentation. It's like a data point addressing. When you have 10 data point, 10 plug. In fact, the first filter is the layer 3. You receive, in fact, the message, and if it's for the device, you go to the top layer, and in the layer 6, it's just the filtering for the variable or the data point you will receive in the message. Layer 7 are not interesting because it's an application, the rule of the job of the device. In the service, we have authentication. Authentication is, in fact, a simple messaging across the network between two devices. One is a simple push button, the second is a door of the bank. And when you press the push button, you ask open to the door. And the door, because he need an authentication, he generate a random value, and this value is calculated with a key, and he resend to the door as a response. And when he received the response, he sent just an acknowledge. I have received your response. He the door check if the value is correct, is calculated with the same key in A or in B. If the key is not the same, in fact, the door stay closed. This authentication, in fact, increase the security for an access point, just per point. It's a simple service. If we compare also a protocol, in fact, we can create compare with different addressing mode. At example, unicast, when one lamp was connected with the one push button in BACnet, you can in fact create a connection between one-to-one. In KNX, there are no one-to-one. It exists, but not for the connection on field. It's always used a multicast. It's the same, but we can create that, but with a multicast address. In LON, you can. In Modbus, it's mandatory because we have not another solution than a unicast. When you want to send a multicast, what is a multicast is one push button to 1,000 lamp. And in this case, the BACnet do not support that. The KNX support only that, and LON support that. Modbus do not support the multicast. And at the end, the broadcast was supported by the BACnet, yes, by the KNX, sorry, the LonWorks and the Modbus. But on field, for the connection, it's always the multicast used. Okay. For the service, acknowledge, unacknowledge, repeat, unacknowledge, it's exactly the same depending on the application. I never ask an acknowledge if I send in broadcast because it's impossible. I have no idea who will receive my message. Which protocol support the acknowledge service? Everyone. The unacknowledge repeat only the LON, and the unacknowledged every last Modbus. And for the authentication, it's very important. In LON, it exists since 1990. It's the beginning. And for other protocol, BACnet and KNX, it's since 2016. In fact, these two protocols will implement not only the authentication but also the encryption of the frame. And in fact, this point is unsupported by the old device. It's very critical for the security for the old installation. Why the security? Why the security is very important in BMS? In fact, it's simple because, in fact, we have different projects and many constraints. If you work on building, commercial building, or residential building, in data center, in home, warehouse, store, electricity, water, food supplier, hospital, you have different constraints. An example, in an hotel, you can manage the comfort in the room, and you can manage, in fact, the access door. In the access door, you need to have more security than the temperature in the room or a light in a room. It's a different. What is requested really by the BAS or the BMS? In fact, the first thing very important. It's ensure it's nominal operation. Nominal operation is working for the comfort, for the light, for access control, and so on. Second point, from my point of view, it's cannot be operated by an unauthorized equipment or operator. It's very important. If you receive an opening command for opening, in fact, each door of the hotel, it's not crazy. Another point is receiving and sending some valid controlling value. In fact, if you have a range of value for a set point, an example between 10 and 35 degrees, this value need to be controlled and managed or by the device or by the SCADA or by everything. In fact, you need to have a value in range and not out of range. It's very important. Another thing is to be able to monitor value by pooling or by event. I have explained just before for the two different vision of the SCADA or on field for the vertical communication or horizontal communication or interoperability. The protocol do not have the pooling and do not have the binding. It's critical in some usage. The ability to modify configuration if you are not authorized. In fact, it's very important that you protect the configuration of each device. This protection can be take different access, or because the device is physically protected, and we will see after. Or the protocol can allow some services to protect some update value. The ability to restore and facility quickly in the event of unauthorized action. It's in fact, if I have a database of all configuration on field, I am more sure that the restart will be easily and quickly made than if I have no if I have different kind of tool. And one question is very important: do my BMS protocol allow this function? What is the installation in real? In real, in fact, on field you have always device on field, device on IP. Repeater for increasing the distance, the number of device on a channel. Switch. A switch is small different than a repeater, and we will see just after. The router filtering some address, and the gateway. The gateway convert a protocol to a second one. In fact, in field you have always the small protocol like DALI, SME, and so on. These protocol manage only small, I don't know, a small number of devices. An example, you have in DALI for the light at maximum 64 devices, but when you have 10 devices with 10 ballast, it's very good. 10 or 12 devices. And because the DALI is not supported a large addressing, in fact, you need to have a gateway, and this gateway exists with a field protocol in DALI and probably field protocol in BACnet, in Modbus, in what you want. The router can be managed different protocol. An example here, the LON. It's the router exists in LON, the router exists in BACnet. Some device in BACnet exist on different medium, exist on IP, Ethernet, and the router can exist also in Modbus. And Modbus, it's a small different because in fact it's not really a router. It's a router. I tell a NAT router. In fact, it changes the address. But in fact, the SCADA have one connection with the IP router. He send an IP router and he asks to one slave behind the router. This is a router. It's not the same than other protocol. And a gateway. A gateway often exists in BACnet or in other protocol. In this case, you split, in fact, the vision from the field and from the main network, often in Ethernet, in IP since 20 years ago. The infrastructure product we have was a repeater. A repeater is just a layer 1 and layer 1. What is the rule of the repeater? It's just amplify. It's amplify in one direction or in second direction, and it try to amplify also the noise. It's not a good thing. And because it's just a simple amplifier, you do not change the speed. You have the same speed in the side A and side B. A switch is different because it calculates in the layer 2 the CRC, and for calculate the CRC, you need to store the full frame. In fact, you can change the speed when you across a switch IP, Ethernet, a switch on LON, a switch on which protocol can support the switch. You can change the speed. And he try to filter automatically some address. An example, in switch Ethernet, he filtered the MAC address. Okay, forget. The router in any kind of protocol have support the router. He changed the speed because it's just on top of layer 2. And he managed the logical address. The logical address is dedicated for the protocol from this router. If it's a router BACnet, he managed the logical address in BACnet. It's a router in KNX, it's a coupler, IP coupler. He managed the logical address of KNX. It's the same in LON. He managed, in fact, the logical address of LON. And the gateway is completely different. The gateway changed the protocol. And in this case, you lose, in fact, the advantage of each protocol, because when you in this free first infrastructure product, the configuration do not need or is not needed for the repeater or a switch. For the router, you need to just configure the router. For the gateway, we need to reprogram the two sides of the protocol, protocol A, protocol B, and the gateway need to converge. When you have a conversion, in fact, you lose the advantage of each protocol. How could an installation be attacked? Oh, by many ways. In first, you can connect a computer directly on field. If it's in LON, BACnet, Modbus, and what you want, the attack can arrive directly on this field medium. For protecting that, you have just one thing, is to hide, in fact, the cable, and you hide any device. It's not easy. The second is when you attack the gateway. You attack the gateway from the media side, okay, the field side. It's the same for the router. In case of the gateway or the router, the attack is only limited to this infrastructure device for the gateway on the router, because it's just a simple protocol, and in fact you can't cross a router with another protocol than the protocol supported by this router. It's very simple and it's protected. But for any device connected to your channel, in fact, the risk exists. The second attack can be arrived by IP Ethernet, and it's a very, very important attack, because the first attack, you need to be on site, and in the second case, you need to can attack not staying inside of the site. In fact, you can send a troll or what you want to aggress, in fact, the installation. You can aggress the gateway, the router, and the big device. If a lot of devices are directly connected on IP, it's more risk than a simple router, because the router can be attacked, okay, yes, but in this case, it protects all the field you have in back. When the attack came from IP, the operating system you have implemented in your device, it's like a security hole, and it's very, very important. You check, in fact, all router, all gateway, if it's resist to all IP Ethernet attack. The first access point was or will be the SCADA. Why? Because the SCADA is it's a computer. In many cases, it's a window computer, and window is known by a lot of hacker. And if the SCADA can be modified for create a modification or an update or a destruction of your installation, you can't protect that. It will be like impossible to protect your installation. This point from the SCADA is very important, and the network can be saved only if you remove, in fact, the SCADA. On infrastructure product or a large device, which kind of attack you can receive? In first, the power on or power down. The second is an attack by the Ethernet port we'll speak about. If you have an access to the device, the SD card, the USB port, and on the serial field on the TP-FT10 channel, if this is a LON, this is an example for the Modbus, for the specific protocol, or for MSTP from BACnet. It's exactly the same. In fact, the risk on the 5 and 6 are less than in 2, and the 3, 4 can modify very easily the operating system and the functionality of the infrastructure product. If you have a field device, you can receive an attack from the power supplies. If you switch off the power supplies, in fact, the room do not make the rule, or the device do not can run this the application, and the other attack can be reached or can be arrived by the field. But this if it's important or dangerous for some application as an access control, fire, and so on, it's limited to the management and diagnostic command. And depending on the service we have, if you have a service with an authentication as example, in fact, you increase the security of your network. If you use on field a big device with a large application, with an operating system like Linux or FreeRTOS, in fact, you are more sensitive to attack. Why? Because in fact you have a full IP stack implemented, and you can support many protocol as FTP, as SSH, as web services, as BACnet, or what you want, or Modbus, and so on. And in fact, you have a lot of doors open for this device. And because this operating system is no Linux or FreeRTOS, in fact, you can have some some attack because the hacker are very intelligent in general, and they try to check if on the CVS database if a device are not up to date by the operating system and so on, and the attack arrive very easily. In fact, the Ethernet and IP are more sensitive than the field device based on a simple protocol than Modbus, than KNX, than LON on TPFT or in BACnet in MSTP. The new generation of device in IzoT, LonWorks IoT, implement, in fact, on a twisted pair, a simple IP stack, a BACnet stack, and a LON stack just behind. And the application are on the very simple operating system, and it's the message arriving by the field is limited, like we have the limitation on a simple LON or a simple Modbus or a simple MSTP device. For installing this or for managing this device, in fact, we need to have a specific router, a standard router, because it's a standardized, it's IzoT router. And this router, it's a LON router supporting the IP routing and the BACnet routing, because you have an IP stack and the BACnet stack. If you have a Modbus stack just behind, in fact, we need to implement the Modbus access. This device will be and is compatible with all LonWorks node installed, and in LON we have installed 150 million of device. In France we have more than 10 million of meters square installed with LON, and this kind of device can be increased and can be give a new vantage, a new value to your investment made many years ago, just by adding some functionality. In fact, the HVAC do not change a lot between 2000 and 2020, 20 years ago. But in fact, an example for the lighting, 20 years ago, the light is just switch on, switch off. Today, we have a dimming lighting. We had a new sunblind. We had new services, and we can probably add this a device based on IzoT. And in this case, we maintain, in fact, the investment of all your investment you have made 20 years ago. For communicate with the LON and the BACnet, you do not need any gateway. Why? Because in fact, it's a manufacturer can create a data point in LON, a data point in BACnet. And in this case, you do not lose anything about each protocol. Why it is very interesting to have these two protocols on the same device? Because in fact you save in fact the energy because it's in fact by the CPU it's 5 times less consuming, and for the just for the transceiver it's 20 times less between the Ethernet connection and the TP-FT10. And the security is also the same than you have in the small device not on Ethernet. Which protocol we can use for security? In fact, a proprietary solution it's very dangerous for evolution. If a manufacturer disappear or remove its protocol, and in the past, an example, Philips used the BATibus protocol. The BATibus was regrouped with KNX. In fact, all device sent by or installed by Philips or by integrator can't be maintained on field. The proprietary protocol is very dangerous. The Modbus have not standardized format data, and it's very dangerous too. Or you protect that, it depends the vision, because if you have not the entire address of each register and the format of the data, because in Modbus you never know if the value is correct or not, because you have four organization of a byte to get a simple register. The register is based on 16 bits. In fact, you have four format for reading these 16 bits. And when you have this 16 bit, you have no idea which is the format. If it's a temperature, if it's a level, it's a counter of water, a liter, and so on. The Modbus is just crazy. The KNX is pretty close with LON, with the functional block, with the different things. But in fact, for the same twisted pair, you can't manage more than 48 messages per second versus 300 messages per second in LON. And in fact, the pooling is impossible. You can't pool. In fact, you need to have in KNX only a sniffer and an infrastructure device following and memorize every message on the twisted pair. It's very, very complex. The BACnet need a proprietary software. In fact, the proprietary, it's the proprietary from the manufacturer. Each manufacturer creating a BACnet device need to have its software for the configuration. In some cases, it's just a simple web page. But if you have a simple web page for configuring your BACnet, it's very difficult to create a large number of devices with different interaction. In BACnet, the connection, the binding, need to be programmed in each device. Why? Because in fact, the connection between two objects are not supported by the protocol today. In fact, all master-slave, all connection between two devices are proprietary solution. It's each manufacturer have invented its solution for creating that. If you want to use another things more open, is to create to use a BACnet device, and you read and write some information like the SCADA. In fact, you centralize the connection between the main PLC and the different device on field. The BACnet have no capability to send a multicast propagation. If you want to send to just in one floor a switch on or occupancy, in fact, you need to send for any room, in fact, occupancy in occupancy in occupancy in occupancy, and you send a lot of message, or you send a broadcast, and in the case of the broadcast, every device receive this information. The BACnet in confront or in versus the LON, KNX, and Modbus is better for many things. The BACnet is better in scheduling, in trending, in alarming management. In fact, the BACnet is better used when you are in the automation layer, not on field, because they lose a lot of things. If you use a BACnet on this on this layer, in fact, it's very important that we cooperate with the second protocol as KNX or LON for the field. Why? Because in fact, the field need to be protected by the attack. Okay. The second is because the BACnet do not support some connection between some device, and the KNX or the LON will support. It's very important that we have something autonomous on field. And for protecting the BACnet layer on IP or BACnet or LON or Modbus and what you want. It's very, very important that the IP infrastructure device have a real router or switch, sorry, with a security functionality inside. It is because I have speak about the OX brass at the beginning of the presentation. And if you try to compare, in fact, different protocol with some level of standardization, the standardization is it's defined for any protocol. For the openness of the protocol, it's exactly the same. For the future implemented in the protocol, an example for addressing for services. In fact, in KNX, it's poor, in BACnet it's poor, in LON it's large, in Modbus it's poor, and so on. Which activity job are described by the functional block? Very poor in BACnet, large in KNX, large in LON, more than in KNX, but we have an example, a washing machine described. It's just in imaging, it's just crazy. IP implementation on protocol, yes. In fact, for Modbus, for LON, for KNX BACnet, it supports the IP, but be careful. An example for the KNX, IP device not often exists. The IP device exists in BACnet. The IP device exists in LON. IP device exists also in Modbus. Infrastructure device. I have not explained every layer, repeater, router, and switch. The most important is the router. In fact, the router exists in BACnet, in KNX, and in LON. Not in Modbus because they are. It's just a router between LON, between IP, Modbus, and MSTP, but it's not exactly a router in this case. We have that. The historical position. In fact, it's the idea, and we will see just in a couple of seconds after this slide. In fact. The position in the history is very, very good in LON because he have never changed or it's completely compatible with the old version. In KNX, it's often the same minus the security because the security was implemented a couple of years ago. And in BACnet, it will change every 3 months. And today we have a new revision of the documentation. It's a BACnet 2020. And I have just downloaded this morning the new Bible BACnet, but it's just crazy. They have, okay, we will see just after. And in Modbus, its position is very bad. In fact, it's very good positioning on market. But on the history, in fact, the Modbus have not modified this vision, and they have not implemented neither the format, neither the interpretation of the data, and not many things. The sustainability of the protocol, in fact, it's very large in LON because you maintain, in fact, the compatibility with the previous and the first device based on this protocol, but in fact it's very small and very small depending on the on other protocol. Sensitivity by attack is small for everybody, for every protocol until you are on this protocol. When you are on IP, in fact, you have, because you are on IP and Ethernet IP, you have this access by the protocol, and you have all other access for SSH, for FTP, and so on. And this is very critical for the attack. Sensitive by device on IP with a router, with gateway, it's exactly the same. I tell yes, be careful. And for that, you need to have a layer just on top of that for organizing the communication between the IP and Ethernet device in any case of protocol. And if the protocol can be apply an authentication, or security. Yes, authentication was installed in LON since 1919, and in fact in BACnet and in KNX. An example, in BACnet, they have removed 1 year ago, in November 2019, the chapter for security, and they have replaced by an annex, and the annex was proposed in last year. Very, very critical, because if somebody have implemented the security many years ago, because it was proposed since 2004, in fact, it's incompatible with the new version of BACnet. And the KNX was implemented the security a couple of years ago, and it's very, very new. And in Modbus, there are no protection, no security. And in fact, we have in the history for different protocol. An example, the schedule, and you will see we are in 2020. The IP, the KNX IP secure, the KNX secure and IP secure starting just between 2010, 15 and 20. It's a couple of years ago. The security is completely changed in BACnet, 100% change 1 year ago. We are in revision 22 in BACnet, and we have started in 2001 with the revision 1. The revision 1, it's always a version 1, starting in 1995 exactly, but they have started with very slowly, and they are increased. And today, they have no device on field certified after the revision 16. It's very, very important, because in fact, you do not implement the new cybersecurity, sorry. They do not implement some object mandatory, because it's necessary to modify everything in revision 17. And the revision 16 have a date of 2012. It's a very, very old, in confront of 2020. The IP encryption that start in 2001 for LON, the authentication in any kind of device implementing LON start in 1990 at the beginning, and a couple of months ago and years ago, new medium but compatible will support the encryption, like HDPLC, like WirelessPass, ISM, RF, with a large security protocol, medium, just the medium. But it's compatible with all you have made before. But the best, from my point of view, stay in fact the LON with the authentication beginning at the beginning in 1990, and you can create and you can modify very simply your installation for maintaining your investment in LON. Thanks for your attention. I don't know if it's possible to have some question. If you have some question, I can probably give the hand to Ernst. If
yes, thanks,
yes.
Daniel, for this presentation and this great comparison between the different protocols. Very good. Yeah, so if you have questions, please enter it in the question box. In the meantime, I can tell you that this webinar is recorded. We will put it, or we will put the link on our website, and I guess by tomorrow it's online, and you can share it with your colleagues or give it or forward it to other person to watch this presentation. So, but in the meantime, no, so far. So if you have any question, or raise your hand.
if you have no question to immediately, but you can send an email to Ernst or to I, and we can send back a response if you need.
Yeah. So if you want to send it to me, it's to tech@lonmark.org, and I will forward it to Daniel. Okay, Daniel, thanks a lot for your presentation. Thanks a lot for the audience for attending this webinar. And sorry that we had to start it a little bit later. Thanks, and
Yes.
bye-bye.
Thanks, everyone. Thanks, Daniel. Thanks, Ernst. Bye-bye.
Thanks, everybody. Bye-bye.